Hello everyone, welcome to our presentation. I'm Raven Santillan, and with me today are Ms. Hernandez, Ms. Gutierrez, Ms. Zabala, Ms. Lorca, Ms. Alava, and Mr. Navarro. Together, we'll discuss the three statistical methods: the Pearson R correlation coefficient, Spearman's rank correlation coefficient, and the Wilcoxon Signed-Rank Test. These methods are crucial for analyzing our data and will help illustrate the relationship and differences we observe. Let's get started.
First, let's discuss the Pearson correlation coefficient. This method is used to measure the strength and direction of a linear relationship between two continuous variables. The result, which ranges from -1 to +1, indicates how closely the variables are related. A value of +1 signifies a perfect positive correlation, -1 indicates a perfect negative correlation, and 0 means there is no relationship at all. It's important to note that Pearson's method comes with certain assumptions, such as the need for both variables to be normally distributed, exhibit a linear relationship, and have no significant outliers. Next, we have Spearman's rank correlation coefficient. This is a non-parametric method that serves as an alternative to Pearson's for assessing relationships. It's particularly useful when dealing with ordinal data or when the data does not meet the normality assumption. Rather than focusing on the actual data values, Spearman's method evaluates the ranks of the data, making it resilient to outliers and distribution concerns. Like Pearson's, it measures the strength and direction of the relationship but is applicable to monotonic relationships rather than strictly linear ones. Finally, let's touch on the Wilcoxon Signed-Rank Test. This is another non-parametric test used to analyze paired or dependent data, particularly when we're interested in median differences rather than means. It's an excellent choice for situations where we have a set of observations before and after an intervention. The assumption for this test include having paired data and a symmetric distribution around the median, making it a robust option when normality cannot be assumed.
So now that we have a basic understanding of what the three key methods of hypothesis testing are, let us now have a deeper look into each one of them and how they are used. So first is the Pearson R correlation coefficient, or most commonly known as the Pearson R. It is used when both the variables are continuous and when the relationship is expected to be linear. So it is also used when the data meets the assumptions of normality and if it has no significant outliers. Here we can see the formula for Pearson R. This formula calculates the linear relationship between two variables by dividing their covariance by the product of their standard deviations. So this standardization ensures that the value of R always lies between -1 and +1. So before calculating for the Pearson R, a great way to visualize the relationship of the variables is through a scatter plot. If the points of a scatter plot forms an upward sloping pattern, it indicates that there is a positive correlation. If the points form a downward sloping pattern, then it indicates a negative correlation. If the points are randomly scattered, it means that there is no correlation at all. Now for the spearman-rho, it is used when the data is ordinal, such as rankings and ratings. It is also used when the continuous data doesn't meet the assumptions of normality or linearity, and used when the relationship is monotonic but not necessarily linear.
Here is the formula for spearman-rho. This formula calculates spearman-rho by ranking the data, finding the difference between the ranks, squaring those differences, and scaling the result to fit between -1 and +1. To visualize this, we can use a rank comparison table. This table can help us determine whether the relationship between the variables are monotonic and non-monotonic. A monotonic relationship is where the variables move in a consistent direction. Positive monotonic relationships show an upward trend, while the negative monotonic relationships show a downward trend. While on the other hand, a non-monotonic relationship occurs when the direction of the relationship between two variables changes at least once. Common non-monotonic patterns seen in the table are usually U-shaped or wave-like patterns. Finally, for Wilcoxon Signed-Rank Test, it is used when working with paired data, like pre- and post-test scores. It is also used when the data doesn't meet assumptions of normality and when you want to test for median differences instead of means. Now, to calculate for the W, we first need to find the differences between paired observations, rank their absolute values, and apply original signs back to the rank. The result helps determine whether the median difference is statistically significant. Since Wilcoxon Signed-Rank Test focuses on paired data, one visualization option could be a paired bar chart like shown. For interpretation, if most differences cluster systematically around 0, then the test might fail to reject the null hypothesis, or it means that there is no significant change. And if the differences are skewed to one side, then it can indicate that there is a statistically significant median difference.
Today, I will guide you through the manual computation of 3 statistical tests: Pearson R, spearman-rho, and the Wilcoxon Signed-Rank Test. Let's begin with Pearson R. Pearson R measures the strength of a linear relationship between two continuous variables. For our example, we have hours of study, which is x, and the test scores, which is y. X equals 2, 4, 6, 8, and 10. Y equals 50, 60, 65, 70, and 85. To compare Pearson R, we follow these steps. Find the mean of x and y. For x, we add all the values and divide by the number of values. Then we repeat that for y. Compute the deviation by subtracting the mean from each value of x and y. Multiply the deviations for corresponding x and y values to get the cross products. Square the deviations for each variable separately. Sum the cross products and squared deviations. Finally, calculate r using this formula. The resulting value tells us how strongly x and y are linearly related. A positive r indicates a positive relationship, while a negative r indicates a negative one. Next is spearman-rho. Spearman-rho is used to assess monotonic relationships between two variables, even if the relationship is a non-linear. In this case, we are ranking two variables, experience for x and performance for y. X equals 1, 3, 2, and 4, and 5, 20, 30, 25, 35, 50 for y. And then here's how we can compute the spearman-rho. Rank both x and y values. Assign average ranks for types if needed. Compute the rank differences by subtracting the rank of y from the rank of x. Square the rank differences and then sum the squared rank differences. Use this formula to calculate the rho. Here, n is the number of data points. A rho value close to 1 or negative 1 indicates a strong monotonic relationship, while a value close to 0 indicates 0 to no relationship. Third is the Wilcoxon Signed-Rank Test. The Wilcoxon Signed-Rank Test is used to compare paired samples to determine if their median difference is 0. Our data here represents the anxiety score before, which is x, and after the therapy, which is y. X equals 10, 15, 12, 20, and 18. Y equals 8, 14, 10, 16, and 17. To compute the test statistic, calculate the differences di equals xi minus yi. Ignore any differences of 0. Take the absolute value of the differences and then rank them. If ties exist, assign average ranks, then reapply the original signs of di to the ranks, and then compute the sum of positive ranks, which is t positive, and the sum of negative ranks, t negative. The test statistic t is the smaller of t positive and t negative. Compare t to the critical value from a Wilcoxon table based on the sample size. If t is less than the critical value, we reject the null hypothesis, indicating a significant difference between the paired samples.
In choosing appropriate test, always remember this.
Implication in psychological research. For this part of the presentation, we will be showing a tutorial on how to implicate this method in psychological research. In this tutorial, we will demonstrate how to perform the Pearson R, Spearman-Rho, and Wilcoxon Signed-Rank Test in both SPSS and Excel. We will guide you through the step-by-step process for entering data, running analysis, and interpreting the results. Here are the steps in conducting Pearson R in SPSS. Number 1. Enter your data in the Data View tab. Number 2. Variable must be continuous only. Number 3. Check the Variable View tab and check if the variables you want to analyze in a set into scale. Number 4. Check if the data has normal distribution. And to check if the data has normal distribution, follow these steps. Number 1. Click the button Analyzed. Number 2. Click Descriptive Statistic. Number 3. Under Descriptive Statistic, click the Explore. And number 4. Move to the Scale Variables Independent List. Number 5. Click Plots and select Normality Plots with Test. Number 6. Click OK. And last, in the output, check the Test of Normality table. Going back to conducting Pearson R in SPSS, the next step is number 5. Click the button Analyzed. Number 6. Select Correlate. Number 7. Under Correlate, select Variate. Number 8. Select the two continuous scale variables only. Number 9. Move the continuous variables into the variable list. Number 10. Under Correlation Coefficient, check the Pearson box only and the Flag Significant Correlations box. Number 11. Go to the Output tab and interpret the results.
Here is the interpretation of the results.
Moving on, we have the Spearman-Rho. Here are the steps in conducting Spearman-Rho in SPSS. Number 1. Enter your data in the Data View tab. Number 2. Variable must be ordinal or scale only. Number 3. Check the Variable View tab and check if the variables you want to analyze is set into ordinal or scale. Number 4. Select the button Analyzed. Number 5. Select Correlate. Number 6. Under Correlate, select Vibrate. Number 7. Select two ordinal or two scale variables only. Number 8. Move the variables into the variable list. Number 9. Under Correlation Coefficient, check the Spearman box only and the Flag Significant Correlation box. Number 10. Go to the Output tab and interpret the result.
Here is the interpretation of results.
Now, for the Wilcoxon Signed-Rank Test in the SPSS, follow these steps. Number 1. Enter your data in the Data View tab. Number 2. Variable must be continuous only. Number 3. Check the Variable View tab and check if the variables you want to analyze is a set into scale. Number 4. Click the Non-Parametric Test. Number 5. Under Non-Parametric Test, choose Legacy Dialogues. Number 6. Under Legacy Dialogue, choose Second Related Sample. Number 7. Select and move the two scale variables into Test Pairs List box. Number 8. Under Test Types, check the Wilcoxon box. Number 9. If necessary, check the option to customize it. Number 10. Go to the Output tab and interpret the results.
Here is the interpretation of results.
So now we're learning how to conduct Pearson's R, Spearman-Rho, and the Wilcoxon Signed-Rank Test in Excel. So let's first have the Pearson's R. It has 9 steps. First is to input your data into Excel. Second is make sure that the data is continuous. Third is the use of this formula. Equals correlation of the cell range of your variables. Example, equals correlation of A2 to A11 with B2 to B11. So this calculates the correlation coefficient, Pearson R, between two continuous variables in columns A and B. So next is to calculate T statistics, use this formula. equals person R cell multiplied by the square root of the count of the cell range minus 2 divided by 1 minus the square root of person R cell. Example, equal cell 2 multiplied by the square root of the count of A2 to A11 and B2 to B11 minus 2 divided 1 minus the square root of C2. The fifth step is to calculate the two-tailed p-value. We use this formula. T-distribution two-tailed of the absolute value of the T statistic cell with the count of the cell range minus 2 degrees of freedom. Example, equal T-distribution two-tailed of the absolute value of C3 with the count of A2 to A11 and B2 to B11 minus 2. The sixth step is select the columns you want to analyze. Next is go to Insert tab. The eighth step is click Scatter from the chart options. And the last step is to interpret your results.
Here is the interpretation of results.
This is how we conduct the spearman-rho in Excel. First is to input your data into Excel. Second is to make sure that one data is ordinal and another one is continuous. Third is to assign ranks based on the order of the ordinal data. Fourth is to make a new column for these ranks. Fifth is rank the continuous data using this formula. Equal rank average cell C2 within the range C2 to C5 is ascending order. Sixth is to create a new column. Next is to subtract the rank order to the ordinal data from the rank order of the continuous data. Example, equal D2 minus E2. The eighth step is to create another column. Ninth is to square the differences. Example, equal F2 raised to the second power. The 10th step is to calculate the totals of the squared differences. Example, equal sum the values in the range G2 to G5. The 11th step is to calculate Spearman's-rho using this formula. 1 minus 6 times cell G6 divided by the count of the range D2 to D5 multiplied by the square of the count minus 1. The next step is to calculate T statistics. We use this formula. Equal person R cell multiplied by the square root of the count of the cell range minus 2 divided by 1 minus the square of person R cell. The next step is to calculate the two-tailed p-value. We use this formula. Equal T distribution two-tailed of the absolute value of the T statistic cell with the count of the cell range minus 2 degrees of freedom. And the last step is to interpret your results.
Here is the detailed summary of what Ms. Alava discussed.
Here are the steps in conducting Wilcoxon Signed-Rank Test in Excel. First is to input your data. Second, calculate the difference between groups using this formula. Example, equal A2 minus B2. The third step is to calculate the absolute differences between groups using this formula. Equal if cell C2 equals 0, return blank. Otherwise, return the absolute value of cell C2. The fourth step is to calculate the rank of the absolute differences between the groups using this formula. Example, equal if cell C2 equals 0, return blank. Otherwise, rank cell D2 within the range D2 to D7 in ascending order. The fifth step is to calculate the positive ranks using this formula. Equal if cell C2 is greater than 0, return the value in cell E2, otherwise return blank. The next step is to calculate the negative ranks using this formula. Example, equal if cell C2 is less than 0, return the value in cell E2, otherwise return blank. The seventh step is to calculate the test statistics. The smaller of the sum of the positive ranks or the sum of the negative ranks. Example, equal the smaller of the sum of the positive ranks from F2 to F7 or the sum of the negative ranks from G2 to D7. The eighth step is to calculate the sample size using this formula. Equal count the non-block cells in the range F2 to G7. The last step is to interpret the results.
Here is the detailed summary of what Ms. Alava discussed.
Thank you for being part of our presentation today. We hope you find the insight valuable. We invite you to ask any questions you may have. Your curiosity fuels deeper understanding for everyone. If you'd like to delve deeper in these statistical methods or discuss their application, please don't hesitate to reach out. We are here to help and would love to continue this conversation with you. Let's explore these topics together.